Thanks, Rob. Like you said, my name is Jamie Butler. I'm CTO at Endgame, which basically means these guys are going to be doing all the talking. I just want to take a quick moment to introduce them. To my right here is Anjem. He's a threat researcher in our R&D department. Came to us by way of Cisco. His expertise is in network analysis and machine learning. This is Andrew. He came to us with a long history, as you can tell by his old age beside me, of doing pen testing and red teaming. He likes to say he spent more time in other people's computers than in his own. I don't judge. So, a really quick agenda. We're all here talking about threat hunting and things like that. And one of the things that Endgame is excited about is to kind of learn from the audience and from the summit of what your thoughts are on threat hunting, because it's like Rob was saying earlier in BAM, it's not really totally well defined, and everybody has a little bit different spin on it. We'll talk about our spin later tomorrow in our lunch and learn. But we're going to talk a little bit about the hunt cycle toward the end. The main topic of the presentation is hunting on the cheap. So we build products and things like that, but we don't want to talk about those. We want to talk about how you can make sure your organization builds some pretty decent hunting capabilities with open source tools, open source intelligence, anomaly detection, things like that. So this is how we would all like to envision our jobs, right? Like we're in Minority Report, we're sifting through data, it's all visual, it's awesome. But it's really, you're kind of down in the weeds, and you're sometimes, as Bam mentioned, maybe you're actually farming with a spoon, it seems. So I want to discuss what we think of adversarial hunting. As Rob said, things have changed in the last couple of years. Everyone assumes breach already. When we talk about adversarial hunting, we're not talking about hacking back. We don't believe in that. We don't think it's lawful, and its attribution is really hard to do. But we're talking about finding and eliminating the evil things or the badness within your own network. And in our interactions with people, it seems to be an evolving field. It's a lot of mature organizations are already doing it, and those that are a little bit less mature are really trying to come up to speed today. We've talked to a few people who actually in the clothing retail end of the spectrum who are building hunt teams, and so things are definitely evolving quickly, and everyone understands the need for hunting. So it's really an interesting intersection, we believe, between offense and defense, and we'll discuss a little bit about what that means. So everyone here can hunt. It sounds like a lot of you already are. There's free tools to do it. There's effective techniques that we feel have helped us in some of our hunting, and you can do it with or without the need for commercial threat intelligence. So what are we talking about hunting on the cheap? How do we go about that? When I think about the security problem, I really think about it from our network devices and from our endpoints or our hosts. Those are they make up the majority of our security architecture and things like that. And so the general hunt methodology that we have outlined here is kind of, we need to be able to collect data, so we need to be able to get things off network devices, that might be NetFlow and other things. Angela will be talking in a moment about network analysis that you can do. We also need to be able to get things off the host. The host is where our assets typically are, and that's where our intellectual property and things like that are. So we want to bring back the data, and then we have to analyze it. So we need to be able to sift through large amounts of data, make interesting conclusions about it, pull the thread and follow where it leads. Once we find something that's bad, then we need to remediate, kick in our kind of IR process. So this talk will discuss the specifics of the network and host analysis. And this is just the beginning. It's a 45-minute talk with some Q&A time, so it's not everything that we would like to be able to share with you, but it's a taste of what we're doing in our R&D organization that we hope will help you. So I'll turn it over to Angela to talk about hunting on the network.
All right, so when we talk about, there we go. So let me begin by explaining what we're trying to achieve here. When we talk about hunting for network IoCs, we look for known bad domains, IPs, CIDRs from a block list that we have bought or acquired. Our challenge these days is that this network IoCs are very short-lived. I'm a big fan of wire, and I think of network IoCs like burner phones. By the time we detect one, adversary has already moved on to the next one. So what we really ought to be doing here is to look for some sort of higher order IoCs, some patterns that reveal the unknown bad. Turns out that passive DNS is really good at capturing such patterns. Passive DNS, as you all know, is the data that we acquire by observing inter-DNS traffic and reassembling the whole DNS transaction. And it is as simple as it sounds. It's a glorified TCP dump with reassembly logic built in. You can use any of these two sensors that we have used in the past and place them on a recursive DNS resolver or on a spam port within your network, and it spits out data that looks just like that. And look how concise and structured that is. You've got your query name, your query type, and your answers. And that's what makes passive DNS really easy to work with. With the background out of the way, let me talk about the workflow. So you first want to know what's normal and popular in your network, and maybe whitelist it out. Then we could slice and dice the remaining data in various different ways to figure out the outliers. And the last step would be to look at those outliers, narrow down on those outliers, and see which of them are malicious. Majority of the time you look at passive DNS data, you will find that the big majority of the DNS queries in your network are repeat queries. So it makes sense to understand what's popular and normal in your network and whitelist it out. Every time I think of popular and normal domains, I think of Alexa top domains. It's a good starting point, but there are some challenges when you use that over passive DNS. Firstly, Alexa captures popularity of websites from a browser perspective. What it doesn't capture is all the sort of SaaS services, the CDNs that actually deliver the content. Think your Akamai's and AWS of the world. Alexa doesn't track all of those domains in there. And secondly, you can't whitelist everything that's in Alexa domains. Typically, anytime if a domain hosts content that it doesn't own or control, you can't just whitelist it out. Example would be dynamic DNS domains. You basically are looking for domains that have large number of subdomains that resolve to a very diverse IP space, both geographically and by ownership. This diversity of IP space is a really interesting topic, and we'll see some more examples shortly. All right. So on to our first hunting technique, fast flux. So fast flux was all the rage back in 2010, 2012 timeframe, where a single domain would resolve to a large number of IPs swapped in and out high frequency, typically to beat an IP-based block list. Now, from passive DNS perspective, it's a domain that has large number of A records, typically with a small TTL. But the challenge is that most load balancers and anycast domains look very similar. But what separates the two classes is, again, the diversity of IP space. Think about it, right? Google.com may resolve to a large number of IPs, but those IPs will be owned by Google. Or Netflix.com may resolve to a large number of IPs, but it will be owned by AWS in different regions. In some way or the other, benign load balanced domains have some homogeneity in their IP space. Hold on, where should I find it? All right. But malicious domains using fast flux techniques tend to have a very diverse IP space. And that's a key here for the key part of the section, right? We are looking for a particular pattern. We didn't know about these domains from any block list. We looked for this pattern, and we found these 3 domains, which I later confirmed were C2 domains according to Yara tutorial. And that's pretty interesting, right? We're just still looking for a pattern, and we find bad stuff that we didn't know about. Next up is DJs. So domain generation algorithms, right? Malwares that use DJs typically generate large thousands of random domains every day and tries to reach out to them. And the botnet controller would register a few of those domains to get the botnet going. And in order to take down the botnet, one has to register all those domains before the botnet controller does, right? Now, that's a challenging problem that we have faced. The thing is that we can measure randomness. If someone is trying to randomly pick characters from English alphabet, he's going to get a vowel 24% of the time, consonant 76% of the times. But English language has a much higher vowel to consonant ratio. Or even the letters that randomly picked letters would be out of order. So if we use some of these features that are listed here and put them into a very simple classifier called random forest classifier, which is like a 20 questions game, we can come up with a really good DJ classifier. We have actually open sourced this classifier as part of this talk, and it performs really well. Now think about how you would do this from a traditional network hunting perspective. We are looking for malware families that produce thousands of domains per day. These domains are never used again. There's a huge list of block lists that you have to maintain. And these domains you can't just extract statically from a malware. You have to continuously dynamically analyze malwares. But if you put this DJ classifier in front of your passive DNS, you're catching these domains as they go live. So that's really powerful. I'm going to keep doing that. And there you go. Oops, skip it. Now, what if a malware family is smart enough to not use random characters, but use random words, put them together to make a domain? And so we're weak with that simple DJ classifier. I don't know if you guys can recognize the family of malware behind these domains. It's nib.dot. But we have another trick against such sort of DJ families that don't really have, that have a different random DJ function. So remember I said the DJ family has thousands of domains that it produces daily, and only few of them resolve, right? Now what happens to the remaining ones? They show up as a DNS error with our error code 3, which stands for NX domain or non-existent domain. Now typically you see 3 to 5% of your traffic as DNS errors with NX domain, typically from copy-paste errors, typos, browser prefetching, malformed HTML, and so on. But anytime if the rate of NX domain surges in your network, there's a high likelihood there is something bad going on. Again, think of this as incorrect password attempts. If you see too many of them, someone is trying to abuse the system. And in this case, it would be a DJ family. So anytime we do outlier detection, there's going to be false positive. Outlier does not necessarily mean malicious. So here's an interesting example. For this talk, we are collecting the material for this talk. We ran some sensors that I mentioned earlier on our corporate network, on our labs, and so on. And we found these domains that were DJ looking. Most of these domains, these queries were NX domains, and the domain behind this was behind a whois proxy. And so we scratched our head for a few days because, long story there, the funny story there. But it turns out it was Chrome's DNS wildcard detection, where a particular user had configured his personal domain as a search domain. So there can be false positives. We're going to touch on two slightly advanced hunting techniques next. First one is periodicity. So network traffic follows a particular pattern. Folks come to work in the morning, take a break for lunch, come back in the afternoon, and then leave for the day, right? If you filter out the domains that receive queries only during office hours, what you're left with is this continuous trickle of automated traffic, right? Within that traffic, we are looking for domains that have received queries periodically. Think of your software update checks, the SSH keep alives, content refresh, and so on, right? A simple way to detect periodicity is take the average time between queries for a particular domain, call that inter-query interval, and see what fraction of domains got a query at that interval given a margin of error. And if that rate is, in my experience, if it's about 75%, you have a domain that's receiving periodic queries. Like I said, normally these are software updates check, OS services checking for updates and calling back. And majority of these times, these domains are posted on well-known, highly available content delivery networks that you have already whitelisted in most cases. What you're left with are our outliers. Now, in my experience, when we have these outliers, there are two kinds of outliers in there. One, there are softwares running in your network that you didn't know about. And two, we have a C2 a malware family, e.g. or not. Again, that's the point here that I'm driving here, that is that we know that C2 traffic is periodic. And if you look for that particular pattern, you find possible anomalies in your network. The last hunting technique that I want to talk about is phishing detection. If you look at these examples here, there are two kinds of commonly used phishing domains. For the first type, the phishing domain is a slightly modified version of a well-known domain. And in order to detect such domains, we could use something called edit distance. When you say slightly modified, that's where edit distance comes in. We can use a function called edit distance to figure out the domains that a particular domain might be trying to spoof. And for the other type, where a phish domain would contain a known brand name to look genuine. And in such cases, you could use a technique called longest common substring search, potentially using the suffix tree, to search for these domains at a very large scale and figure out domains that a particular actor is trying to phish. In our experience, most of APT actors these days are using phishing domains to exfiltrate information out of the network. So this makes it a really good technique to figure out, hunt for APT actors. Now, like we saw earlier, outlier doesn't necessarily mean malicious, right? So we need to do some validation. So in my mind, I would do 3 steps to validate a particular outlier. Have I seen it before, or is this a new behavior? Maybe go back a month back and see if you had seen this before. How many hosts in your network had this particular outlier? More widespread, larger the number of hosts that have a particular outlier, less likely that it's going to be malicious. And how many models were triggered for this particular outlier? You've seen throughout the slides, I didn't find a single malware that didn't have multiple sort of hits of outliers sitting on them. Once you filter past, these outliers get past those filters, maybe you want to drill down to the process and user level and see who generated traffic and is it still malicious. And if so, start the IR process. And if it doesn't, you want to maybe consider adding that particular domain or that abnormality domain as a normal into your whitelist list. We touched on 4 or 5 hunting techniques today, but we have really just scratched the surface. You can develop so many more hunting techniques on top of passive DNS based on current trends, and don't really have to know a known bad IOC. But there are 3 main guidelines for developing hunting techniques on passive DNS. 1, every network is different. You have to find what's normal for your own network. It's a learning process. On the same token, what's abnormal for your network is something that you have to maintain and know. It's something that you have never seen before. Maintain that list of suspicious domains that you have never seen before. And lastly, we have only spoken about what was queried and what was the response. If you also include who queried and when, you make your models really, really accurate. And on that note, I'll hand it over to Andrew to talk about hunting on the host on the cheap.
I'll just yell. Oh, there we go. We're good. Okay, so I'm going to try to figure out this. I'm going to talk about hunting on the host, doing a lot of the really similar things that Andrew was just talking about, finding badness with either something sort of to start looking from, or start looking at, or with nothing and just kind of going out in the blind on the cheap, of course. So let's see. So the general idea when we're talking about finding badness on the actual host, right, so basically, we're going to say that you've got lots of hosts in the network, and they're going to be somewhat homogeneous, and that's probably going to be as a byproduct of the fact that you either have GPO that's configuring everything in some semblance of the same way, or that you use some kind of image when you were setting up your network. You use a workstation image, you use a server image, something or another like that. So the software that's going to be installed in this, the different things that are going to run on each of these machines are typically going to be at least somewhat similar. They're not going to be identical because people actually do stuff on computers, but they're going to be somewhat similar. And so if you want to find things that are bad, you can start by just finding things that are weird. Just because something is weird doesn't mean it's bad, and so on and so forth, but that is a really good place to start. So a lot of the there's a number of different things that you can look at when you're looking at the hosts. You can look at the processes, just the processes that are running, the network connections that are taking place, items on the file system, logs, autoruns, etc. You have to figure out, which of the things based on your network you want to try to look at. Some are going to be more effective than others, but there is no right way to do it. There are some cheat codes that you can use a little bit that are overall relatively effective, and I'm going to talk about some of those here now. If I can get this to... There we go. So the two overarching scenarios that I'm going to talk about today are hunting with open source intelligence, or otherwise just hunting with any piece of intelligence where somebody tells you exactly what you're looking for, you just don't know where. And then the other thing is going to be hunting with no intelligence. You have no idea what you're looking for, but you're just going to look based on anomalies that are in your network, and you're going to then investigate those. And you're going to look at things that stick out, and you're going to go based on that a little bit. So first, we're going to talk about hunting with intelligence on the cheap. So this, as I was kind of saying before, you have some kind of indicator of compromise, like a hash or even maybe like a TTP write-up or something like that, a file name something, and you want, I'm so sorry. I'm just dirtying up this thing for everybody else. It feels so bad. And I have to buy another one for you guys. And so you're going to have some kind of indicator of compromise that you're going to want to apply to your network, and you're going to want to actually reach out and do something to try to find where that indicator exists. It could be a file hash. It could be a complicated set of strings. It could be a signature. It could be something like that. And one of the things that we're going to talk about is actually just using the native functionality in Windows administration, like PowerShell, to actually reach out and use something like Yara to actually check for a signature once you get a piece of intelligence that or an indicator, and you're going to reach out and actually use it. And then hopefully once you find something bad, you have a remediation process, or you can kick off the response process to obviously undo whatever badness was done there. There's a lot of different places where you can find open source threat intelligence in one form or another. This is not an exhaustive list. This is basically a list of places to start, and all of the different formats that these are going to give you some semblance of open source threat intelligence is these are going to give it to you in different formats. Some are just going to be big piles of malware. Some are going to be blogs, and some are going to be places where they actually have well-written IoCs and such. You don't necessarily know which, it depends on how you're going to be looking for things. This is just a handful of places to start. One of the things that I'm going to talk about a little bit today is actually Yara. Can you raise your hand if you've ever heard of Yara before? Awesome. Can you raise your hand if you've ever used Yara before? All right, that's still a good amount of people. So if you haven't heard of Yara before, you can kind of think of it as like grep on crack for binaries. It's basically like if grep became like self-aware and just like crawled out of your computer. Basically what it does is you can use very complex types of logic where you basically define a bunch of strings, or you define binary byte patterns or byte arrays, and then you introduce logic where you basically say like, okay, here's a rule for this this malware family or this packer or whatever, and then you'd name a bunch of conditions in here, and I'll actually show you an example rule after this. But it basically can scan files on disk, or it can scan things in memory. And Yara is really cool because it's open source, it's free, it's great, but it is not cool because signatures are brittle. They're not, all a bad guy has to do is just change his malware in some way or another, and your signature's broken and it doesn't work anymore, which sucks. But it's free, so you get what you pay for. And you can still, there's a lot of good that you can do with it. The value that it really gives you is that if you have an indicator, if you have a good Yara rule for a bad guy or a group or a campaign that somebody knows about that they inform you of, you can use Yara to just figure out on a given host whether the badness that exists is present or not. You just reach out and you can just check, and it gives you the answer back, and you can kind of go from there. This is an example Yara rule, so you can see a little bit. That's probably not big enough to see, but that's fine. And basically, this is a Yara rule for a tool called Mimikatz, which is a tool that's used both by kind of red teamers, pen testers, and also actual bad guys. And it's used to actually extract plain text credentials from memory, and a couple other tools that do the same thing. It being present on a host is an indicator of something bad going on, probably. It's a tool that's used, it's been written up before by a lot of different people, but this is just an example. The actual author of the tool wrote a Yara signature for his own tool, which is actually a pretty cool thing to do. And you can see in there it defines a couple of the different byte arrays, and then if we were to go down further, it would actually have the conditions that it would look for in a given file. But if you know, like, oh, I'm going to use this rule, I'm going to apply it to an entire host or to a given directory, oh, I see Mimikatz right there, that's definitely not good. And so this is just an example of kind of what the makeup of the rule is. So if you wanted, you can use PowerShell native Windows functionality to actually go out and transfer the Yara binary over to another machine and then actually just remotely execute it against your rule set. And you can do that natively with PowerShell. You can do that with GPO. But basically all you're doing is, I've got kind of an example here, copying the actual Yara binary to a machine or a set of machines. If you've got like a text file that has a list of all of the machines on your network and you're able to authenticate to those, which, as we were talking about before, may not always be as easy as I'm making it sound, but that's a battle for another day. And then you copy over a rules file, and then you can basically just remotely execute a command to say, hey, I want to run this Yara rule against a folder, or against an entire host, or against, any given location to try to find if there's some kind of badness or not. This lets you know if you have a set of rules, or if you have a rule, if you're trying to check for something, if there's any badness that you already know about. For example, a lot of the badness that people are going to detail in some of the open source intelligence sources that, the open source threat intelligence sources that I was citing earlier, they're not going to always be talking about the ultra sexiest of sexy bad guys, but they are going to have some semblance of a baseline of things that you should have the ability to check for. Unfortunately, as I'm sure a lot of people are going to talk about today, malware changes really fast. It's not very hard for a bad guy to alter their malware sample, their implant, their backdoor, or whatever, so that it kind of finagles its way around signatures. So signatures are great, they're really useful, but they're not always sufficient. And that actually brings me to my next point, hunting with no intelligence, where you have no idea what you're actually looking for. Again, of course, on the cheap. So one of the things I'm going to talk about a little bit is auto runs. Basically, long and the short is, there are, as I was saying before, there are lots and lots of different places for you to look for badness and for you to collect the data that you're going to use to try to identify anomalies. Auto runs is actually a really great place to start, because an auto run is just characterized as something that just starts up when you start your computer. And bad guys really like to hang out. Once they compromise your network, they want to stay there. They have things that they want to do. They want to have more evil things. They want to be able to come and go as they please. So they're going to leave a little treat for you that runs every time you reboot your machine, and that would be persistence. That's going to take the form of an auto run. And an auto run can actually take a bunch of different forms on a Windows host. I've got a couple of them listed here, the registry run keys, like run and run once, the different Windows services. There's a way that you can have drivers do it. You can slip into, like underneath the operating system in the BIOS and stuff like that. There's a bajillion different ways that you can get something to actually run, but you can actually get a really good, relatively comprehensive picture of the different auto runs using actually some really simple tools that I'm going to talk about today. So one of the tools I think, and if you're actually looking at doing something like this, if you have the ability to go through and check, identify all of the auto runs in your network, it's actually really, really effective. Like I said, looking at anomalies in auto runs it doesn't necessarily mean that something is bad, but it does mean that something is weird. And if something is weird, then there's a good chance that it's going to be bad. So one of the tools I'm going to talk about is actually sysinternals autoruns. Super, super, super useful. It's a tool from Microsoft. and it enumerates like a ton of different places where something is actually starting up, something is running automatically, both with service startups or service auto runs, the registry auto runs that we were talking about before, drivers, lots of different things like that. If you just run it with all options enabled, it'll give you like, I mean, it's normal to see like 100 different things come out, but you can filter it down based on slightly simpler things. Like if you just want service auto runs, or if you just want user level auto runs or something like that. One of the really nice things about sysinternal's auto runs is that it will actually also hash the auto runs for you. So it'll take the files that everything's pointing to, and it'll SHA-256 it or whatever, and it can automatically like shoot them off to VirusTotal for you to just go ahead and say like, oh, it's kind of like Clippy. It looks like you're looking for badness. Like, you want me to go ahead and check VirusTotal for you? Sure. So you can do that, and it's actually really useful. You can actually, like I was saying before, you can use autoruns to natively shoot stuff, or use autoruns to automatically shoot stuff over to VirusTotal. But you can do the similar thing that I was talking about before with using a Yara signature. When you have a bunch of hosts and you have a Yara signature and you want to apply that to a bunch of different places, you can actually do the same thing with autoruns and the dependency DLL. You just copy them over to the systems that you want to run on if you have the ability to do so. And you can actually run that to enumerate all of the different autoruns on that particular machine, and then you can pull all of that data back, and you can start stacking it up together using some really, really simple just command line one-liners to actually do the actual text manipulation to find anomalies. You can take all of these and you can submit them to VirusTotal. If anything comes back from VirusTotal, you know it's bad, then you know, all right, that's a good place for me to go ahead and start looking for badness. Or you can build something yourself that uses the VirusTotal API. You don't necessarily have to use sysinternal's autoruns to do this. So if you were to do that, if you were to run autoruns, get hashes on a bunch of different hosts on your machine, like we were talking about, pull all the data back, and then you were to sort it in just a way, you were to have a script that sorts it in terms of IP address or host name, and hashes of the actual autorun items, and you put it in this format, you can stack stuff up in such a way where you're like, okay, let me sort things out and then unique everything together so that I just have, it reduces everything and puts a little number next to it of all those different occurrences. And then I see everything in a descending order. You'll see that, okay, for these top, 10 items, all 42 of the machines that I saw had that same startup item. Great. Same with the next one and the next one and the next one. But then for the bottom two, for some reason, there's only one occurrence of both of those hashes in the network once I've actually reduced this data together. Like, what is that? And so you can go back and you'd grep against, or you'd control F to find, which host was this autorun, was this hash an autorun item to, and you can see, okay, it's this host right here. And then you'd go back and you'd find that file in the raw data, and you'd say, hey, what is this? And you go through and you look at it and you're like, oh, holy crap, this, for some reason, this version of VMware Tools has a different hash from all the other ones. Did somebody actually backdoor this binary? Is this just a different version of the binary? I've found something weird, and you can actually move from there using no signatures whatsoever, just some kind of basically anomaly detection of auto-run items in your network. Yes?
Hey, do you guys have any methodology on fuzzy hashes?
The question is, do we have any methodology?
Jesse Kornblum.
The question is, do we have any methodology on fuzzy hashes? What do you mean methodology? So they're using fuzzy hashes.
Doesn't have that capability.
Right, so fuzzy hashes, for some of them, are a huge pain on Windows. Like, for example, getting like SSD to work programmatically on Windows sucks because they give you like a pre-made binary that you can use, but there's no like programmatic way to use it on Windows. For background, SSD is a hash that basically lets you find, instead of with, for example, an MD5 or SHA-1, where if you change 1 byte, it changes the entire hash completely. A fuzzy hash is more malleable. If you change 1 byte, it doesn't change the entire hash. It maybe changes one part of the hash, and that lets you find file similarity. That's, I think, more useful if you have a fuzzy hash of a piece of malware and you want to find other malware of the same family that's really similar.
But I don't think it's going to be I'm not sure that it would be as useful if you fuzzy hash all of the auto runs, for example, in your environment. I don't know, I'd have to go back and look to figure out the value of that, but I think it's the majority of the value is going to be, I get a fuzzy hash for something that's bad, I'm going to try to find things in the same family that are similar to that kind of bad, if that makes any sense.
There will be a fight between Jesse Korblum and Andrew at lunch.
Hi.
Hey.
I'm Jesse Cornloom. I wrote SSD.
Fuck, I'm sorry.
Two things. One, I disagree with you. There is an API for SSD, and we can talk afterwards. I'll show you how to use it.
I'd love to.
But secondly, I completely agree with you that SSD isn't very good for looking for known for this kind of problem, because the variants that you'll find of known good files are other known good files. So you'll find the next version of whatever DLL or utility you were looking at.
Okay. Thank you. Thank you for being here. Thank you for all your work. And extra credit from some of the stuff I was talking about. You can do this with any number of technologies, but taking all the auto runs. Well, you can just pretend that there's a slide here that has the Elasticsearch logo, and long and the short is, extra credit, take all of the auto runs that you have over time, dump them into something like an Elasticsearch cluster or a database or something like that, and just look at how they evolve over time. And basically, this gives you the ability to say, to go back and say, did I ever have this particular item in an auto run ever? Or when did this change happen in my environment? So on and so forth. And yeah, so that's extra credit for hunting on the host. And with that, back to Jamie.
Can you hold on one sec? I'll just do the concluding remarks and then we'll go to Q&A. We've talked about a few ways that you can hunt both on network data and host data. It's not an exhaustive list, but it should be enough to help get you going. We're around the next 2 days for questions and so forth if you want to talk. We try to present some of the things that we found useful in our work and our research. We're also doing some stuff I want to talk about that was, I believe, maybe in the abstract, but we didn't get a chance to talk about today, and that is something we call Faraday. So Andrew will kick me, but it's his project. I call it a global honeynet. He says no. But that's basically, it's there on the internet getting attacked all the time. And we get a lot of really useful data around that. And so that enables our hunting as well. It's kind of like an IoC for bad things like bad IPs or bad tool sets that are dropped on our honeynet once an attacker compromises it. So if you want to talk about that with him after the talk, come up to Andrew. Maybe the slides will change. This is really crappy. I said don't do a build out. Endgame kind of thinks about the hunting cycle a little bit different than some. It includes surveying the network, securing your hunting ground, detecting the anomalies and so forth, and then also surgical response. So if you're interested in hearing about that, Lyndon Brown has a lunch and learn tomorrow where he'll go into a little bit of that hunt methodology. And with that, we're at the end, and so we'll take any Q&A that you have.